The last topic we cover in Module 4 is dividing polynomials, also known as polynomial division. So please make sure you are completing your guided notes as you watch this video. So when we're dividing polynomials by a monomial, what we want to do is break them up into separate fractions, and then we're going to divide the coefficients and use our exponent rules to simplify them. And that's only when we're dividing by a monomial. So here, if I have f divided by g of x, where f of x is my numerator and g of x is my denominator, I can rewrite this as 15x cubed over 3x squared plus 3x squared over 3x squared. What I've done is I've pulled my fraction apart. I can then simplify as I normally would. 15 divided by 3, that's 5. X cubed over x squared leaves me with just x. In my second term, I have 3x squared over 3x squared. 3 divided by 3, well, that's just 1. X squared over x squared, that's x to the 0, or 1. So fully simplified, this would be 5x plus 1. That's when we're dividing by single term monomials. So let's do a few examples of that. So if I have 15x squared plus 20x minus 5, what I want to do is I want to pull this apart. So I'm going to go ahead and have 15x squared plus 20x minus 5. I'm going to write that as 15x squared over 5 plus 20x over 5 minus 5 over 5. And then I can simplify. 15 divided by 5, that's 3. X squared is my only variable term. 20x over 5, that becomes 4x. And negative 5 over 5 becomes a negative 1. That's how I'm fully simplified. In example 2, I have negative 12x to the 8th plus 4x to the 6th minus 8x cubed, and I'm dividing that by 4x squared. So I can rewrite this as a polynomial divided by a monomial, and then I can pull my fractions apart. Negative 12x to the 8th over 4x squared plus 4x to the 6th over 4x squared minus 8x cubed over 4x squared. Negative 12 divided by 4 becomes a negative 3. X to the 8th over x squared becomes x to the 6th. 4 divided by 4 is a 1. X to the 6th divided by x squared, that becomes x to the 4th. Minus 8 divided by 4, that's going to give me a 2. X cubed over x squared gives me an x. And then I always check to see if I can combine like terms. But in these examples, I cannot. Our last example of dividing by a monomial has not one, but two variables. I still am going to follow the same rules where I pull this apart into fractions, and then I simplify each term using our exponent rules. So I'm going to have 8xy squared over x squared y squared minus 9x squared y over x squared y squared plus 6x squared y squared over x squared y squared. In this first term, I'm going to get 8x to the negative 1, because we take 1 minus 2, that's negative 1, and my y's cancel. Minus 9, my x's cancel, but I've got y to the negative 1. Plus 6, my x's cancel and my y's cancel. I then remember how I feel about negative exponents, and I push all of those negative exponents to the denominator. So fully simplified, I get 8 over x minus 9 over y plus 6. So all of these examples involved us dividing by a monomial. But what am I going to do if I'm dividing by a binomial? Well, for that, we need to use a different process, and it's really similar to long division like we used to divide in high school and middle school and elementary school, like before you were allowed to use a calculator. We've got to go old school for a little bit. So let's remember the process of long division, and then we're going to see how that compares for dividing polynomials by a binomial. So friendly reminder that long division is the process of dividing two numbers by hand to get a remainder. For example, 2 doesn't divide 9 evenly. We're always going to have a remainder of 1 because 9 is an odd number, and I could rewrite 9 as 4 times 2 plus 1. We divide the dividend, that's this, by the divisor to get the quotient, right? Remember when I'm dividing something, I'm asking you to find the quotient. This is our quotient, and whatever's left over is going to be our remainder. So let's do a couple examples of numerical long division so we can kind of remember this process. So if I have 49 divided by 3, I'm going to rewrite it like this. And our first step is, okay, how many times does 3 fit into 4? Well, 3 fits into 4 once. 1 times 3 is 3. 4 minus 3 is a 1. And we pull down the next term. Well, now how many times does 3 fit into 19? 3 fits into 19 6 times. 6 times 3 is 18. We subtract this in order to get a remainder of 1. So our quotient is 16 and our remainder is 1. Our next example, I have 344 and we're going to divide that by 11. So I try and look at 3 and 11 doesn't fit into 3 at all. So then I can look at 34. Well, how many times does 11 fit into 34? It fits in 3 times. 3 times 11 is 33. We subtract. I get a 1 and I pull down my next term. This pulling down the next term, this pattern is going to be really crucial when we're dividing by a binomial. How many times does 11 fit into 14? Well, that's 1. 1 times 11 is 11. We subtract to get a remainder of 3. So 31 is my quotient, and 3 is my remainder. So now that I've taken this way back, let's see how this applies to polynomials. So here are steps for dividing a polynomial by a binomial. Okay, so the first thing we need to make sure we do is arrange our terms in order of descending powers of the variable, meaning from largest degree to smallest. And this is a good habit to get in always. The next thing we're going to do is divide the first term in the dividend by the first term in the divisor. What does that mean? Well, let's work through this example. So I've got x minus 5, that's in the correct order, and we're dividing x squared minus 17x plus 74. So I'm going to take my first term in my dividend and the first time in the divisor, and I think, okay, what do I multiply x by in order to get x squared? Well, that's going to be an x, because x times x is x squared, and x times negative 5 is a negative 5x. That was actually step 3. We multiply every term in the divisor by the first term in our quotient. This is our quotient, what we're forming up top. Then I go ahead and subtract, right? It's the same thing we did with long division. We multiply and then we subtract. I always make sure to put in parentheses because this negative has to distribute to my second term. So I have x squared minus x squared. Those should cancel out. If they don't cancel out, we made a mistake, and that's okay, we can fix it. But here they cancel out. Then I have negative 17x minus a negative 5x, so that's plus 5x, right? That gives me negative 12x, and then we bring down our next term, which in this case is a plus 74, right? We then repeat this process. This is an iterative process, meaning it repeats. And we do this until the remainder can no longer be divided by our divisor, which is x minus 5. So what do I multiply x by in order to make it look like negative 12x? Well, that's a negative 12. Negative 12. Negative 12 times x is a negative 12x. Negative 12 times negative 5 is a positive 60. And then I subtract. 70 minus 60 gives me a positive 14. This is my remainder. And x minus 12, this is my quotient. So I can rewrite this as x minus 12 r 14, or I could write this as x minus 12 plus 14 over x minus 5, because it's what I would have left over and what I'm dividing by. Let's do multiple examples. Before we start doing our examples, though, I want to show you this another step-by-step worked out version of this type of problem. And you can see me solving these types of problems. This is polynomial division. I've got multiple videos on YouTube, and I'll be doing a bunch more examples in this video. So you have lots of resources, but here's like a typed up, slightly blurry example. So first example, I've got 2x squared plus x minus 10 divided by x minus 2. So the first thing I do is I make sure all my terms are in order of power from largest to smallest, which they are. And I look at my first term of my divisor and my dividend in my divisor, and I say, okay, what do I multiply x by to make it look like 2x squared? Well, that's 2x. 2x times x gives me 2x squared. 2x times negative 2 gives me a negative 4x. And then I subtract. My first terms will cancel out. X plus 4x gives me 5x. And I bring down my next term. What do I multiply x by to make it look like 5x? Well, that's going to be a 5. 5 times x is 5x. 5 times negative 2 is negative 10. And when I subtract, I get no remainder. That means that these are perfect divisors of each other. So I could rewrite, if I wanted to, 2x plus 5 times x plus 2. That would give me the numerator. That would give me 2x squared plus x minus 10. And I could check my answer if I wanted. But this is a perfect divise. X minus 2 is a perfect factor, a perfect divisor of 2x squared plus x minus 10. And those are rarer to find with long division, with polynomial division, but they aren't impossible. Next example, I have 3x squared minus 2x plus 5. And we're going to divide that by x minus 3. What do I multiply x by to make it look like 3x squared? That's going to be 3x. 3x times x is 3x squared. 3x times negative 3 gives me a negative 9x. And then I subtract. Negative 2 plus 9x gives me a 7x. And I pull down my next term. What do I multiply x by to make it look like 7x? Well, that's going to be 7. 7 times x is 7x. 7 times negative 3 is a negative 21. And then I subtract. 5 minus a negative 21, that becomes a plus. So my remainder is 26. So I can write this as 3x plus 7, remainder 26, or 3x plus 7 plus 26 over x minus 3. It's our remainder over our divisor. That gives us that fraction. In example 3, I have 7x minus 9 minus 4x squared plus 4x cubed over 2x minus 1. And my first gut instinct should be, okay, these are not in the correct order. I need to put them right. So I've got 4x cubed minus 4x squared plus 7x minus 9. So this one's going to have another round of steps, because instead of a degree 2 polynomial, like our first two examples were, this is a degree 3 polynomial. So what do I multiply 2x by to make it look like 4x cubed? That's going to be a 2x squared. 2x squared times 2x gives me 4x squared. 2x squared times negative 1 gives me a negative 2x squared, and then I subtract. My first terms cancel out. I'm going to have negative 4x squared plus 2x squared. That gives me a negative 2x squared, and I pull down my next term. What do I multiply 2x by to make it look like a negative 2x squared? That's going to be a negative x. Negative 2x times 2x gives me a negative 2x squared. Negative x times negative 1 gives me a positive x. I subtract. 7x minus x gives me 6x, and I pull down my next term. What do I multiply 6x by 2x by to make it look like 6x? That's going to be 3. 3 times 2x is 6x. 3 times negative 1 is a negative 3, and then I subtract. My 6x's cancel out. Negative 9 plus 3 is a negative 6, so negative 6 is my remainder. So I have 2x squared minus x plus 3, remainder negative 6, or 2x squared minus x plus 3 minus 6 over what we were dividing by, that 2x minus 1. For our last example, if you aren't using a pencil, I suggest you do so because I'm going to be asking you to erase. So let's take a look at this example. I've got 8x cubed minus x 1 divided by 2x minus 1. So I set this up and I think, okay, what do I multiply 2x by to make it look like 8x cubed? Well, that's going to be 4x squared. 4x squared times 2x gives me 8x cubed. 4x squared times negative 1 gives me a negative 4x squared. And then I subtract. My first terms cancel, which is great. But how do I have negative 1 minus a negative 4x squared? These terms aren't the same, so I can't combine them. This is going to leave us a mess of trouble unless we put in placeholders. So let me erase what I was doing, and now I'm going to do this again, but this time with placeholders. So I have 2x minus 1 and 8x cubed plus 0x squared plus 0x minus 1. I need to make sure that every single possible term that could happen, or every single degree of x, is present, because it's going to be critical for me to be able to subtract like terms. So like I said, 4x squared times 2x gives me 8x cubed. 4x squared times negative 1 gives me a negative 4x squared, and then I subtract. Now I have 0x squared plus 4x squared, so I get a positive 4x squared, and then I pull down my next term. It doesn't matter that that term is 0x. I need to be able to pull down the next term. What do I multiply 2x by to make it look like 4x squared? That's 2x. 2x times 2x is 4x squared. 2x times a negative 1 is a negative 2x. I subtract to get 2x minus 1. What do I multiply 2x by to make it look like 2x? That's just going to be 1. 1 times 2x is 2x. 1 times negative 1 is negative 1. When I subtract, I get a remainder of 0. So my quotient is 4x squared plus 2x plus 1, and there is no remainder.